Problem 10. Let's have a look. Which one of these number written in base 10 does not end in the three digits 101 if we were to write it in base 2, i.e. binary? Oh boy. I am not so sure if I like this problem. First of all, it's saying it's talking about binary numbers, which I really need to refresh my memory on that, because I don't know about you, but I don't deal with binary numbers on a daily basis. And then of course there's the whole other part of it, which is I'm thinking that's probably gonna result in us having to write out a bunch of examples. So let's get started. I don't know what you're thinking here, but I would start with just remembering what's the difference between binary and base 10 numbers, and is there a way for me to go from one to the other? So is there a way for us to convert base 10 numbers into binary numbers? All right, so let's just write down the regular base 10 numbers first. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Of course, that makes altogether 10 numbers. Now, what do you do when you're out of numbers and you still want to count higher? Well, what we do is that we just say, well, we already counted up to 10 once, right? And we want to start doing that again. So let's say 1 for having counted up to 10 once, and then having reset our counting again. Let's start counting again. Let's do 1, 2, 3 again, all the way up to 19, where we again ran out of numbers, and now we already counted up to 10 once, and we did it once again, so that's 2 altogether. So there's 2, and then we start counting again. So that's kind of the idea of using the 10 numbers that we have to make any number that we want. Now, binary numbers work in exactly the same way. The only difference is that you have 2 numbers to work from rather than 10. So apply the same logic to count up to higher numbers with binary. 0 and 1, of course, would be exactly the same. And then for 2, well, you ran out of numbers. Well, you can say, I've counted up to 2 once. So that's almost, and so used to writing binary numbers or base 10 numbers that I started writing 2. That's going to be a 1. And then you say, we want to start counting again. So there is no more. So that's 1, 0, looking like a 10 to a normal person, but 2 to people who understand binary. And then let's do that again. So we're counting up again. We got a 1, 1. And then again, we ran out of numbers. We got to do another digit. And then, of course, we want to do a 0 on both of these. And then we start doing that again. And what do you know? Now we have a 101, which we have here. Okay, so that's interesting. So now we understand how to go from base 10 numbers to binary numbers. Let's try to go a little bit deeper and really try to understand what's happening here. And how do you kind of build binary numbers? So let me just write down a little bit, a little table that will make sense in just a little bit. So I'm gonna do 2 to the power of 6 here. Then I'm gonna say 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, and 2 to the power of 1, and then 2 to the power of 0. And I want to make a little table out of this. I'll see if we can do a nice table. There we go. All right, so once this is written, I want to write down what that results in here in the base 10 number system. So of course, anything to the power of 0 would just be 1, and then you have a 2, and then times 2, that's 4, 8, 16, 32, and 64. Okay, and then I want to make another line here, and then I want to see how is it that we're building up certain numbers. So let's say that we wanted to create 4 here. how do we create a 4 out of these numbers if we only have these numbers to work with? Well, a 4 is exactly a 4 right here, which I have here, right? So I can say I want one of those. Thank you very much. I want one of those. Well, since I've already chosen a 4, I gotta choose if I want or don't want the numbers that are smaller than 4. Do I want a 2 on top of that? No, I don't. 0. Do I want a 1 on top of that? Nope. So that's just a 0. And this makes 1, 0, 0, which is a 4. Okay, that works. What about 5? Well, 5 would be similar. So you would have, you do want a 4. You want a 1 as well, because 4 plus 1, that makes 5. But you don't want a 2. So that's a 1, 0, 2. Let's do another one. Let's do a higher number. Let's do 9. So what would 9 be? Well, the way that I would think about this is, well, what's the highest number that I have here to deal with? I definitely want one of those, as long as it's not higher than the number that I'm dealing with. Well, that number in this case would be 8, so I definitely want an 8. Now, after that, for 9, if I already have an 8, the only thing that I'm lacking is a 1 to make the 9 whole. So I don't want a 4, and I don't want a 2, and I do want a 1. So this would be a 9. Okay, so in this case, if I were to write this down, or actually let me take one more example and then we'll write it down in a different way. Let's say that we had 13, for example. 13 would be, well, what's the highest number here that we can use? So it would be 13, and then looking for the highest number, which is 8 in this case. Let's say that we are getting one of those. So then we write a 1 for that. Now we've already had it, right? So we can take that away from 13 to deal with the rest. So what would that be? 13 minus 8, that would be 5. And then now we have a new number. For this number, what do we have here? We got a 4. So we want that once, right? So we will just do 4, 5 minus 4. And we're going to say 1 for that. That gives us 1. And of course, when we have 1, we can just say a 1 for that at the end. And then, of course, we're not using any 2's here, so we write a 0 for that. That means that 13 is 1101. So now maybe you're seeing where I'm going with this. Because what is it that determines that the last 3 digits is going to be 101? Well, that's this part right here. If you do this process of first taking the number that you're dealing with and finding the highest number, 2 to the power of something that creates the highest number, in which case, in this case, it was 8. And then you're saying, okay, once we've taken that, let's take that away from the main number and then say that we already have one of those, right? We can take that away, and then let's do the same process again. So we basically are coming up with an algorithm that hopefully should always end in end in some small number, like a 1 it did here. And then as long as we at some point get to 5, we know, oh, if we're getting down to 5, then the last digits of this binary number is going to be a 101. And that is exactly what we are after. So let's actually try to do that with these numbers. All right, so let me take away some of the stuff. And I'm going to actually take away this as well. All right, then. So let's try. So for quick reference for myself, I'm going to write down the different to the power of 2 numbers that we want to be dealing with. So I'm going to say, oops. There we go. So we want 2 to the power of 0, which is 1. 2 to the power of 1, which is 1. 2 to the power of 2. Oh, sorry. What am I talking about? It's 2. 4 to the power of 3. That's 8. 2 to the power of 4. That's 16. 2 to the power of 5. That's 32. 2 to the power of 6. That's 64. 2 to the power of 7. That is 128. And 2 to the power of 8. That is 256. 2 to the power of 9. It's going to be 512. And let's do one more, and then we can add more later if we need it. 2 to the power of 10. That's going to be 1024. All right. So now let's see. For 5, of course, we know that 5 ends in 101 because it is 101. So we can take that away. Can cancel that. Can't be that. Let's try with 333. So 333 minus, what's the highest number that we see here that goes into, or, that can go into 333 once? Well, the one that I see is this one, 256. So 256. And let's take that away from there. So let's do this. This would be a 13. 13 minus 3, that's going to be a 7 left. And then you have a 10 over here. It's 12 minus 5, there's 7 as well. And then, of course, we only have a 2 left here, so there's nothing here. That's 77, all right? So 77 being the new number. What's the highest number that we have that go, okay, that's like 64. So let's do that. 64, this is going to be a 3, and this is going to be a 1. 13. Let's do a 13, although we've already done this earlier in this video. 13, which is going to be that. That's going to be 8 going in there. So that's going to be a 5 at the end. And there you go. That's our little ding, ding, ding. We got a 5 at the end, which means that it's going to end in 101. So it can't be this either. Now, let's try the other number. 549. What's the highest number? That's definitely this one. 512. Take away from that one. What's this going to be? So this is going to be 7. So it's going to be 37. Okay. And then we have the highest number for that, 32. Take that away. And then, of course, that's going to give us 5 again, which again means that it's going to end in 101. Take that away. Hopefully it's going to be the next one. Let's have our fingers crossed. 615. And then what's the highest number there? 512 for sure. 3, 0, and 1. Okay, 103. Which number is the highest one? Again, that's 64 for that one. And then do a minus again here. And then we'll have to borrow from this one. And then this one here. So that's 13. And then that's going to be a 9. And then there's going to be a 9 there. So that's going to be a 39. So 39. And it's going to be 32. Which is going to be, how much is that going to be? That's going to be a 7. That's interesting. So 7, what's the highest number that goes into that? That's a 4. Which means if we take 7 minus 4, that's not a 5. That is a 3. Which means that this number is not going to end in a 101. Because it doesn't have a 5 that it ends with. So therefore, it must be D. Hopefully that was understandable and not too convoluted. There are other ways of solving it too. As long as you figure out that the five at the end is what is making it 101, you can also you can take away 5, for example, from the number and then do some divisibility tricks on it to figure out the right number. But I thought this was the easiest way to solve this problem.